I'm Ava.
And I'm Beth.
This is COWculus AP.
Are you ready to graph this function? I am. On today's episode, we are talking about rational functions. F of x equals x plus 2 divided by x. We're going to look for horizontal and vertical asymptotes.
So we're going to start by looking for the horizontal asymptotes, if there are any. And what I'm looking at here are the x's. There's the x in the numerator and the x in the denominator. And they have the same degree. They're both x to the first power. So that means we just have to sort of divide away the two x's and find out what the coefficient is. In this case, it's just 1. If the denominator had been a 2x, then the horizontal asymptote would have been 1/2 and so on. But all it is here is y equals 1. For the next part, we have to look at the vertical asymptotes. And for that, you just have to look at the denominator and set it equal to 0. In this case, when x equals 0, x is 0, so that's all you have to do. But if the denominator was something else, like x plus 2, then the vertical asymptote would be x equals -2.
An important thing to note is in our graph, it might look like the graph crosses the asymptote. However, this does not, and this is really, really important to note. The graph will never cross any of the vertical asymptotes.
With horizontal asymptotes, it's a little different because it's more like if the asymptote is 1. As x goes towards infinity or negative infinity, the function will approach 1. The function may cross the horizontal asymptote, but not in this case.
Sometimes you have to use a slant asymptote because the horizontal asymptote doesn't exist. This is when the numerator or top degree is greater than the bottom degree, which is the denominator. There's two methods to do this. We're going to look at method 1, which is called synthetic division. For synthetic division, what you're dividing by has to have a degree of 1. Otherwise, you would have to divide multiple times, and it would make it more complicated. So what you do is you take the coefficients. In this case, we're taking 1, 3, and 5, as I circled, and you're going to divide it by -2. And how we got -2 is x plus 2 equals 0 when x equals -2. You bring down the 1 and then you multiply it by -2. Then you bring it back, so you add 3 plus -2. Then you multiply the 1 times -2. You add 5 plus -2 to get 3. So you have a remainder of 3. But you don't care about the remainder because you have your equation y equals x plus 1.
You might be wondering, why is there an x there, and how do you know that 3 is the remainder? This is why. Well, the x squared is going to divide away because you're dividing and you're going to end up with a factor. So the first number that comes out is going to be the coefficient for an x value rather than an x squared. That's just something you have to remember when you're dividing polynomials. So the next number is just going to be a constant, and then since there's another number, you know that is the remainder.
Now for the second method, you might be familiar with it as it's been talked about in other classes like pre-calculus. So to solve this problem, we're going to need to do some long division. We're going to have an x at the top. We carry down, we do some algebra there. When we simplify, we get x, and then we bring down the 5, so we have x plus 5. X plus 2 times 1 is the closest thing you can get to x plus 5. So that's why you add 1. Then we multiply x plus 2 times 1, so we get x plus 5 minus x plus 2 with the remainder of 3. You'll get the same answer for both methods because they do the same thing. They're just two different ways to do this problem.
Hey, just to clarify, when you're doing a slant asymptote, the degree in the numerator can only be 1 degree higher than that of the denominator. It can be x squared over x or x cubed over x squared. But there will be no asymptote at all if it's x cubed over x. Then the slant asymptote doesn't exist. How do asymptotes relate to calculus? Limits!
Thanks for watching this video. Feel free to comment and subscribe and drop a like.